Thank you all for being here today afternoon and attending my session. Before we get started, can I have a raise of hands if you know what generative AI is or have used it at all? Okay, that's great. And a raise of hands if you know what agents are or have used them before. Okay, awesome. So I think we got a great mix of crowd over here. And most of you know either of them, but I hope that by the end of this talk, you have some fair understanding of what generative AI is, but also really focus a little more on agents and how exactly you can build applications using agents, but with some open source frameworks for building different Gen AI applications. So I'm Hema Veeradhi. I'm working as a principal data scientist at the Emerging Technologies team at Red Hat. I'm based out of the sunny state of California, but I'm originally from Bangalore, India. I've been at Red Hat for 6 years now, and I've personally seen the entire landscape of AI evolve and transform. I personally think it's an exciting era that we're in the world of Gen AI, and I hope that by the end of this talk, you'll also share in the excitement and the enthusiasm for this new wave of technology. If you wish to connect with me later on, you can find me on LinkedIn, but I also work on a lot of different open source projects that we do with Red Hat, so you can also find me on GitHub if you would like to see what are the different projects that we work on. So in today's talk, I want to briefly give an introduction to generative AI, but also go in a little more deeper into what AI agents are or what LLM agents are, and also give you an explanation of how they work, what are the different components involved when you think about an agent system, and then finally go through a live demo where you can see some of these agents in action and see what they're capable of doing. And lastly, leave you with some thoughts around how you can use open source to advance most of these AI initiatives and AI missions that you're probably working on within your companies and organizations as well. And finally, leaving some room for any questions and further discussions. So lots to cover, so let's get right into it. Now, AI is not new. It's been with us for many, many years now, as you can see on the screen. These are some of the most popular tools and technology that we have all been using over the past few years. Some of them have become an integral part of our lives, and so AI has been around for many, many years now. For example, Google search, right? It's nothing but a machine learning algorithm, which is a PageRank algorithm. And all it does behind the scenes is trying to scrape all the different web pages that exist on the internet. And based on a user's input, which can be a keyword or a topic, it tries to run that model, which is a page ranking model. Based on the relevant context of the user's input, it tries to fetch all these different web pages and rank them in order of the most relevance based on your input category. Similarly, Amazon.com, it introduced online shopping to us. It also has machine learning models at the back end where it's running certain models on top of your data. So it's analyzing a customer's browsing patterns or shopping patterns. And the end goal is to improve or enhance their shopping experience on their website. So if you're like a frequent gardener and you're always buying gardening plant equipment and so on, the algorithm tries to learn and recommend things which are of similar nature or which might be useful to you based on your browsing capabilities. So just like that, we have social media platforms, you have TikTok, Instagram, all of these have models behind them which are training on the user's data. So it's very customized on the type of data that you as a user are generating on their platform. And they are basically recommending you content by understanding your data, by understanding the patterns of your data, and giving you content on these platforms which may be of interest to you. So what exactly is generative AI, and how is this different from all the AI or machine learning models that we've been seeing or we've been using over these years? So just like the name suggests, generative AI refers to machine learning models that particularly can create or generate new content. Now, this content can be in the form of text, it can be in the form of code, audio, text, images, and so on. And the differentiating factor with these models is that they also mimic human-generated output. Now, if you think about that a little more deeply, this is very different than what your traditional machine learning algorithms were doing, like the PageRank algorithm or the recommendation algorithms with all these technologies that we just saw. It's very different because here you're actually interacting with this model in a more human language conversational form. So that's where this generative AI technology is differentiated and how it's different. And unlike this traditional machine learning models that were trained on analyzing existing data, which is in the case of Google search, the web pages. In the case of Amazon, it's the user's browsing patterns. Apart from those existing data, what large language models are trained on is they learn from data and they generate outputs that resemble or that mimic the training data. So these models are called large language models, which have these type of generative capabilities. So models like GPT, Gemini, Mistral models, Llama models, all these different models that you might have heard of in the last couple of years are nothing but large language models. Now, why are they called large language models? It's just because of the large corpus of data that they have been trained on. So as we're trying to mimic the output of, the LLMs are trying to mimic the output of what data it's been trained on, so higher the quality of the input training data, better is their generative capabilities, and better is their ability to understand the structures, the relationships that exist between this vast amount of data. And that's why we call them as large language models. And as I said, once they've been trained, they can generate outputs that mimic the training data that it was trained on. And you can also think of a large language model as a highly creative student who has read every book in the library, who has studied every painting in a museum, or has listened to like every music that ever was created. So now this highly creative student can go and write their own books. They can go and create new paintings in different styles, and they can even start composing their own songs, right? Based on all the knowledge that they have absorbed. That's essentially what a large language model is doing. You're trying to make it understand and absorb as much knowledge as you can so that it's able to mimic and produce similar type of actions or types of outcomes that you would want these to do. So how do we exactly interact or use these large language models? Now, traditionally in previous machine learning models, they were always kind of running in the background, so it was mostly at a back-end system. So you weren't necessarily directly interacting with it, but you were rather interacting with like a front end, which would then make calls to that model, like Google search, for example. Now, the difference in a large language model is it follows a question and answer type of format which you can interact with. So it's like a chatbot type of interface. So if you've ever opened Gemini or you've opened ChatGPT, you'll see that it's a chat window. The reason for this is because the LLM takes as an input from the user what we call as an input prompt. Now, these prompts can be questions, they can be a user request that you are describing the model so that it can do some XYZ task for you. So that's the input prompt that you provide. And then finally, the LLM can give you an output in a structured format which is human readable. So it can generate an output in the form of text. Now it's even capable of generating images and audios, and even code for that matter. So this is kind of the input and the output of how LLMs actually are working. So just as the AI technology, as we saw, has evolved, so is our interaction with it. So traditionally, let's say I were to plan a trip to Japan. how would I do this before ChatGPT? I would go to Google search, and I'll enter keywords like places to visit in Japan, because it's my first time there. And Google search would give me a bunch of web pages, mostly ranked in the best order of relevancy. And me, as a user, would probably go and click the first 3 or the first 5. And then at my own time, I would try to summarize what each of those web pages were doing. And then I'll try to come up with the curated itinerary for my upcoming trip to Japan. Now, cut to now with the capabilities of LLMs. What I would instead rather do is ask the LLM directly, hey, I'm planning a trip to Japan. Can you suggest me a 5-day or a 7-day itinerary for this? And that's exactly what these models are capable of doing, giving a certain type of an input. And based on that large corpus of data that I spoke about, they are able to generate that content for you. So here, my input was that prompt, suggest an itinerary, and the output is this structured response in a human-readable format, which is plain English. And it even gave me like a breakdown of day 1, day 2, day 3. These are the things that you can do for your upcoming trip. Now, it's actually reduced the number of steps that I would have done prior when I was just looking at Google search, because I was going through those content myself, I was browsing it, and then figuring out an itinerary. Whereas here, it's already doing that job for you, and it's even giving it in a more structured format and allowing you to kind of take the bits of the response depending upon what you're interested in. So now let's say I want to go a step further, and I want to ask it a certain task, or rather want to give it a certain task of, can you now book me the flights or the hotels for this upcoming trip? Raise of hands if you think this is not possible. Raise of hands if you think this is possible. So exactly, so that's where agents come into the picture here, and that's why this new wave of technology that has kind of caught the attention of a lot of us. And what these agents are capable of doing is essentially adding that component of reasoning and planning, but not just that, going a step beyond and actually performing an action for some sort of a goal-directed task that you may have. So what exactly are these agents? They are nothing but your large language model systems that use the LLMs to perceive, to reason, and to act. And they're basically acting in a goal-directed manner. So similar to how we were interacting with the LLM, you were asking it to do a certain task. That's exactly what we're doing with the agent, but with a furthermore capability of autonomously making those decisions and trying to plan out those steps independently. So instead of providing a static or a single prompt to your LLMs, the agents will operate in a more ongoing loop where it continuously reasons and plans and breaks down the steps required to solve that particular task. So essentially, it's trying to mimic the human thought-like process. So as humans, given a problem, we always try to break it down step by step. We break the problem into smaller subtasks, and we try to solve accordingly. So that's exactly what these agents are trying to do as well. And they also have are designed in a way that they can autonomously make those decisions and also take actions by themselves. So often over extended period of time, you are giving a flexibility to the agent to also get access to external tools and services. And based on that, you are autonomously letting it decide and make decisions and perform these XYZ tasks. So now that we know what exactly are agents, what are the different components that go behind an agent system, or what we're now calling as an agentic application or an agentic system? So the main components is primarily the large language model. That is going to be your compute engine, which acts as the brain behind everything, because that's where these reasoning capabilities are all coming into the picture, is you have some LLM in your system. The second is the planning component. So as I was saying, it tries to mimic the human-like thought process, and this is what we refer to as chain of thought process. So a lot of these models have these chain of thought algorithms. Some of them are being designed to include this chain of thought architecture inside of them. But this is essentially the planning component where it tries to break down the input prompt given by the user into a more step-by-step planning approach. So that's the planning component of it. The other one, main component, is the tools. So here, tools you can think of as any external service, application, executable APIs that you would want your agent to get access to. So traditionally, when you're just talking to Gemini or when you're just talking to GPT, you are only dependent upon the data that it's been trained on. But how do we give it additional accesses? You can upload documents when you're chatting with Gemini or GPT, but how do we give it access to, let's say, my email? I want to send an automated email every Friday to my team. I want to send an automated message on Slack every week. How do you do those things? These are nothing but the tools that you are extending the LLM to get access to, and that's essentially what we are calling this entire agent setup, is you are allowing it to talk to these external services inside of your organization's applications. The other main component is memory. So like every application, there is a memory that needs to be taken care of for agents. Typically, it's of two types, short-term and long-term. Short-term is for the thought chain and steps that it takes. That's in the short-term memory. The long-term memory is more for storing the sessions that a user has with the LLM. So if it wants to retain the conversation that it has had, those are going to be stored in this long-term memory component of it. And the last component is the action. So finally, what action do I want my agent to perform? Whether it's sending out an email, sending out a Slack thread, booking those flights, booking those hotels, whatever it is, those are those additional actions that these agents can take on behalf of the user. So now that we know what agents are and what are those different components, how do you actually start building agents, or how do you start using them? Well, the good news is there are already a lot of open source frameworks that exist which provide you a way to define agents and start building a framework where you can integrate them into your existing GenAI applications. Now, there are various frameworks, and each of them have their own sort of features with their own targeted use cases and their pros and cons. But the most common ones, or the most popular ones that I think is relevant, is firstly LangChain or LangGraph. This is a very popular framework, mainly because of its sophisticated library and also its large active community. It's also very modular in nature, and it's written in Python, making it very easy and extensible support for a large number of tools that you would like an agent to get access to. Another framework that's becoming more popular is CrewAI. CrewAI is more of an enterprise, or I would say a production-ready framework that you could use. It supports more advanced and complex agent workflows. So if you're trying to do something very simple, it may be a bit of an overkill, maybe trying to do CrewAI, but it's more suitable for, let's say, multi-agent architecture where you're trying to communicate between agents and do more of these type of collaboration work between agents, then CrewAI is a great framework that you can leverage. The third one that I want to talk about is LlamaStack. LlamaStack is, again, an open source framework by Meta, and Red Hat has recently been collaborating a lot with LlamaStack, and we've also done a lot of work around using LlamaStack and trying to build agent applications using LlamaStack. Some of the features with LlamaStack is that it's a fairly lightweight framework, so you can easily deploy it locally, on-prem, on the edge, on the cloud. The other aspect of Llama Stack is that it provides standardized APIs for all the different components of your agent. So as we saw, there are multiple components. Llama Stack offers an API for managing the memory. It offers an API for managing evaluation and all these other different pieces of the agent framework. And lastly, it follows a client-server architecture. So it's also easy to scale because of the nature at how this framework has been developed. So now that we know about these frameworks, I also want to introduce you to MCP. I'm sure a lot of you have heard about this, but it's also a very relevant topic that you should think about when you're talking about agents. MCP is nothing but a standard open source protocol that's been implemented by Anthropic, and it stands for Model Context Protocol. You can think of MCP like a USB-C port for all AI applications. So just like how USB-C provided a standardized way for us to connect our devices to different peripheral devices and accessories, similarly, MCP gives you that standardized way to connect your AI models to different data sources and tools. And the main goal of MCP is to enable AI agents to be more contextually aware and also making agents more secure. So by having this standardized protocol of enabling agents and allowing agents to talk to themselves, you can allow more easier way of interaction between agents, irrespective of the platforms or irrespective of the frameworks that you're trying to use. So even if it's LangChain, even if it's Crew AI, MCP is basically a standardized way of allowing communications between agents, between the tools that these agents have access to. So this is a very simple diagram that is taken directly from MCP. It, again, follows this client-server architecture. So you see here that there are servers which basically have access to those tools that we were describing. So this tool can be maybe your company's backend database, some file storage. So all of these are being connected to via those MCP servers and tools. And then you will connect to it like any other client-server architecture through a client, which can be your own AI application. You can use the MCP client. And then there's also a host where typically where your LLM model is deployed so that it can connect to these different MCP servers and perform whatever XYZ task you are allowing the agent to get access into. So what this all means is that we aren't just allowing the AI to talk to itself, but rather you're allowing it to dynamically connect and interact with all sorts of external tools and data sources, but in a secure and effective manner. So it's truly bringing AI to your data and not the other way around. So now I want to look at a real use case or a small use case, I would say, of how agents can be used to solve a certain problem. So the use case here is there's an IT team at Red Hat, and they want to leverage LLM agents to enhance their operational efficiency and their incident response management. So they have a bunch of applications or services that are running on a cloud infrastructure platform, and whenever a service or an application goes into errors, it usually results in a lot of manual tasks that are triggered for the DevOps team or the SRE teams, wherein they take more time to figure out what are the errors and try to flag down those services or flag down those applications and then start their incident response. So they're looking to leverage AI and see if they can enhance this incident response by autonomously allowing an agent to, or autonomously allowing an AI application to detect those services or try to send some kind of an automated trigger or a notification to the relevant teams well in advance. So how can we use agents here? We can use agents, like I said, to allow it to access those external tools or services, so allowing it to access that backend where those applications or services have been deployed, allowing it to get access into their logs, using an LLM to analyze those logs, analyze those data that's coming from those applications and services, and then finally doing some kind of an interaction where we can send an automated message or a notification via Slack or send an email and so on. So very simple example, but this is a way that we can think about to start using agents. So to do the demo, I will quickly change my screen here. Just a second. All right. So I'm going to show you a Jupyter notebook that explains how we will be using the LlamaStack framework, but I will also open up this cluster. It's going to take a while. But while it does that, so Jupyter notebooks are interactive code, UI applications that data scientists typically use to start prototyping and building code. So in this example, what I'm doing is I'm trying to connect to my LlamaStack server, and I want to create an agent that can access certain number of tools and give it some instructions as to what I want it to perform. So the first thing that I'm going to do here is, as I said, LlamaStack is a client-server architecture, so I need a client to interact with my server. So I'm going to be downloading this Python LlamaStack client, and with LlamaStack, they have their own agent functions and modules that you can import. So those are basically the steps that I need to do in order to start using LlamaStack. And also, as we saw, every agent system requires an LLM. So we currently have 2 models running. There's this Granite 8 billion model developed by IBM, and then there's also a Llama model that we have deployed on our cluster, and which we want to connect LlamaStack with. So that's what this particular code is going to be doing, is trying to connect to those LlamaStack endpoint and the services. And once it does that, we also need to give it access to certain number of tools. So there are, like I said, I wanted to access the logs of a certain application or a pod that's running. So for example, this is where we usually deploy all our application. This is an OpenShift cluster. So every project or every namespace will have a bunch of deployments and pods that are up and running. I'm not sure if the internet is slow but what's going on. But usually, we have a bunch of pods that run actively, which are containerized applications. So we will see a bunch of pods popping up over here for different applications and services that we deploy on top of the platform. So what we're trying to do over here is get access for the agent to talk to these different tools. So I wanted to connect to this MCP tool, which is an OpenShift MCP tool, which will go and fetch logs for some kind of application. I also wanted to connect to an MCP Slack tool because I want to send an automated message to Slack. So all of these tools have been deployed by us, but these are all public tools. So somebody else actually wrote these tools, and we just had to deploy them actively. So that's one great thing about MCP, is that there are already so many tools and servers that have been deployed, that have been defined and written by other developers. So you can easily go and look up if there's something that's of interest to you, you can probably reuse that. You don't have to write your own tool. So Slack was one such example. There was a Slack MCP tool written, which can easily send messages via Slack. So once you allow your LlamaStack server to access and connect to those tools. Oh, let me see what's going on. OK, so it connected to the server. It connected to this Granite model. And now I'm going to ask it to connect to these tools, which is my MCP OpenShift tool, my Slack tool. There is a model system prompt. So system prompts are basically prompts that you give the model to give it a certain role or tell the model that you are an assistant, you have access to some XYZ number of tools, and make sure that you always use a tool to give a response. So that's kind of like you're giving a default system prompt to the model. And now what we want to do is define an agent. So here is where I use the LlamaStack agent library function. I connect to it using my client. And then this is the model that I wanted to connect to. So I'm going to connect to that Granite 8 billion model. And these are the tools that it has access to, that Slack tool, the OpenShift tool. And then finally, these are my input prompts. So I'm asking it, can you view the logs for this particular application pod? And can you summarize the logs of that pod? Tell me if there's an error. And if there is, please send out a message to this channel on Slack. So that's kind of the input prompt that I'm giving. And my agent now has access to all of these tools. So you can see here the breakdown of the steps that I was talking about. It's trying to think and figure out what are the different steps it needs to take. So firstly, it goes and calls this log tool, which is in that OpenShift tool. And then it goes and finds the logs of that pod. So these are the logs of what it found from that pod. Next, it's summarizing the logs of that pod. So it's saying that the logs indicate some error, the container failed due to some unexpected issue, et cetera. And then lastly, I said, can you summarize this and send it as a message on this demos channel on Slack? And then it's going to execute that. And then now it finally said it's been successfully sent. So let's go and check. So this is the demos channel on Slack. 3:35, so just about a minute ago, it sent this message saying this was the pod, this is the error status, and this is the explanation of whatever the logs were going on. So all of this was autonomously done by the agent. So I didn't have to do anything over here except give all those access to those tools, have an LLM, which is my main computing engine, have a framework which allows me to build an agent system. Yes, I'm doing it in a much more code-heavy manner over here, but there are now easier ways where you can have UIs to build and drag and drop agents, making it more user-friendly to people who are not as technical. But that's just a very small example that I wanted to show in terms of how agents work and how you can use them to start automating or doing certain tasks which you are confident that it can do by itself. So going back to my slides, let me go here. So some concluding remarks that I would like to highlight over here is the agent paradigm shift is all about transitioning from a reactive to a more proactive approach of building your AI applications. So it's allowing you to not just statically do some kind of Q&A or some kind of question and answer with an LLM with single prompts, but rather making it more proactive, making it try to be more intelligent, and incorporating them in your day-to-day workflows. And secondly, there's a huge open source advantage over here in the sense that a lot of these frameworks that I spoke about are all open source, and they have all been developed and constantly being evaluated. And in fact, there's been more work done to make these frameworks more extensible. And finally, our mission as a community is to always build the future of AI in a more responsible, ethical, as well as an accessible form. So what I really want to take away, want you to take away from this talk is to, if you're new or if you're just learning about this AI space, I will encourage you to be part of this mission, to not be overwhelmed, to not be scared of this technology, but rather to really learn about its capabilities, to explore, to contribute, and to also start building things, even from your day-to-day activities. You will be really surprised to see the capabilities of this new wave of technology. And hopefully you'll also learn along the way, as we're all learning. With any new technology, it's not foolproof. So do take that with a word of caution. Like, do really evaluate how you're using this type of technology, because there's still a lot of work being done as we speak. Even now, there's a lot more things that needs to be done to get these models to be more reliable and to also evaluate them in a more effective and secure manner. So with that, I have some resources that you can check out. These are some GitHub repositories that our team has created. The one on the left is a more exploratory repository, which goes through different agent frameworks. So we've explored and done some demo code for like 6 to 7 different open source frameworks. The one on the far end talks more about LlamaStack. So if you're interested in building things with LlamaStack, or if you want to see some examples and demos, you can check out that repo as well. And that ends my talk. Thank you all for listening. That's my email if you want to reach out or connect with any other questions. But I do believe we have 5 more minutes for questions. So I'll stop now to see if anyone has any questions. Thank you. Yes.
I'm sorry, I'm going to geek out a little bit, but you gave a great example of how MCP is like USB Type-C.
Yeah.
I want to go into the computer, and I want to ask about DIMM slots,
Yeah.
IMM. So is there a standardization for bringing your own memory and context to different LLMs? And the reason I'm asking this is that I think as we start to build more and more interesting applications,
Yeah.
I think the value in any agentic system is actually in the context, in the post-reinforcement.
Yeah.
It's the post-learning that happens. It's not just the LLM, it's
Yes.
how we use it.
Yeah.
And that's really the value.
Yeah.
And I don't want to be locked in to any one LLM. So is there some standardization that's happening around long-term memory,
Yeah.
short-term memory, and being able to take it from one LLM to the other, much like you would with the DM?
Yeah, no, great question. So at the moment, when it comes to just LLMs, and like if you want to pass on information from one to the other, majority of these LLMs, the outputs of them, if you see, is more like in a JSON type of structure. So that's usually the metadata format for a large number of these models. So parsing JSON is probably one way of sending information across models. But I would say now, with agents becoming more and more the norm, there are being more protocols around how you can have a standardized way of agents talking to each other. So you might have heard of A2A protocol. So these are more in that realm, because what agents are doing are essentially talking to an LLM, getting the response of the LLM, and passing on that context to the next agent, which is also, let's say, talking to another LLM at the background. So you can have agents configured in a way which are talking to different type of LLMs. So these protocols are moving in that direction of standardizing, not just across frameworks, but also, to your point, across how the messaging of one agent and one LLM gets passed on to the other. So I would say that is probably the most recent one, which is trying to standardize the way that we pass the messaging around different models.
If I can just follow up, if nobody else.
Yeah.
It feels to me like what's missing is a way to define a standard way to, for defining not just context. Because context typically is, we know, it's like, it's whatever, it's the modality, or it's, you can have a long context, but it's really related to a single
Yeah.
It needs to be, I think there needs to be a separate definition for the thing that's the long-term, I don't know, memory, I don't
So,
know-how, you know,
yeah.
that needs to be shared across agents, which I don't think exists yet.
Yeah, no, good point. I also don't think there's a standard way of doing any, like memory management at the moment, I would say is still kind of a black box just because of the way the platforms that people are deploying agents can be vividly different. So for instance, the demo that I showed you, most of the stuff that I have deployed was on an OpenShift cluster, which is like very specific to Red Hat and a Kubernetes way of doing things. So I think memory also kind of seeps into the infrastructure layer at which you are building those agents, and also how you have deployed your large language models. So the Granite model or the Llama model that I used in my demo, we are self-hosting them in the sense that we are using VLLM, we're running it on our own GPUs. So a lot of the components of like an end-to-end AI application, you can see that there are so many pieces of which each and every part of that entire workflow could be running somewhere else entirely. So I think that's why standardizing a way to manage memory is a harder problem, just because every component has its own way of running. So you can probably talk to any model that's hosted somewhere else. You don't necessarily have control over it. So I think these are the things that more challenging, but yes, definitely something to think about as we start building and scaling out these applications. But yeah, good question.